and welcome to the Jones Seminar Series on Science, Technology, and Society. Technology is the application of science to practical purposes, and today we have what I think is going to be a pretty practical talk looking at the equipment that's scattered around up here, and I'm greatly looking forward to it. Our speaker today is Bob Walker, who's founder, president, and executive director of Sustainable Energy Resource Group, a nonprofit organization founded in 2002 and located in Thetford, Vermont, which is about 10 miles north of here. SURGE promotes energy conservation, efficiency, and renewables by forming and consulting with town energy committees. Bob's a certified energy auditor. In 1992, he wrote Earthrights Institute's Guide to Town Energy Planning in Vermont, and he's also director of the Elizabeth Mine Study Group, working on the cleanup of an abandoned Superfund site, and chair of the Thetford Energy Committee. He has been a social, political, and environmental community organizer and an activist in Vermont since 1979. Please welcome Bob Walker.
On now. Can folks hear me okay? Yeah. All right. If anybody can't hear at any point, please let me know. Thanks for all coming today. I realize this is taking place at Thayer. I'm not an engineer. I do have some knowledge about the technology of home energy saving, and I'll try to share that with you. If it gets really heavy into engineering questions, I may not be able to address those, but I'll let you know if I can't. We have a lot to cover in this time, so if there are questions, if you don't understand something that I say, please ask, or if you have a question that might be generic to everybody else, please feel free to ask. If you have specific questions on issues that might be relevant to your home or something and maybe not to others, I'll definitely be around afterwards. Please feel free to come up and talk with me about those things. Just briefly wanted to go over a couple of things that are on the back table. SURGE is a nonprofit. We do have a mailing list that's back there if you're interested in getting information. We send out periodic notices about energy saving opportunities. Looks like I have an email coming in, excuse me. We have a sign-up list. If you want to get periodic notices on energy-saving opportunities, upcoming events, you can sign up on that. This flyer will tell you more about SURGE. We have a program where those who make tax-deductible contributions of $50 or more to SURGE can get discounts from local renewable and efficiency dealers on products and services. That talks about that. This yellow sheet is kind of a synopsis of a lot of what we're going to go over today, with a diagram on the back of typical areas where homes lose heat, so that might be of interest to you. This pink sheet, if you want to try to figure out how efficiently your home is heating, this talks you through the process of figuring out how many BTUs your home uses, dividing it by the square foot of heated space in your house, and gives you some kind of guideline as to how efficient that is. And then on the back are some energy saving tips. And this is information on our home energy audit services. So please feel free to pick any of those up, and there's some books that you can look through in the back as well. SURGE does do home energy audits through a program called Home Performance with Energy Star. If you want to find more about our service, you can look on our website. If you want to know more about Home Performance with Energy Star, you can look at EPA's website and look for Home Performance with Energy Star. Okay, so I guess we'll get going. This is a program that was put together for homeowners in Vermont. I helped put together the educational curriculum, the PowerPoint, and other materials for it. And last year we did workshops in 100 towns throughout Vermont, and we're trying to do it in 100 towns this year as well. And I'm now in the process of working with some folks to make it into a New Hampshire program as well. A lot of it is relevant to any homes. Some of it is specific to each state. So I may have some of the New Hampshire material in my head as we go. If not, get in touch with me and I can get that to you as we go forward. So we're going to try to touch on how homes lose heat, how do you identify and find those areas, what are some simple do-it-yourself measures that you can do to try to solve some of that heat loss, what are some more advanced things that you're probably going to have to hire a professional to do, and what are some health and safety related issues that come into play as you start to tighten up a house, and finally some technical and financial resources that are available. This is an example of a house that went through the home performance program. They ended up, after doing these measures, air sealing, insulation, tuning up their burner, and sealing their air ducts, saving 340 gallons of oil, which was $900, at a cost of $6,600. So a payback of less than 8 years. And that's typical, probably 6 to 8 year range for payback on this kind of efficiency work. And if you think about it, that's a pretty good return on your investment, much better than you're getting most places today. So it's worthwhile. Not only are you saving energy, improving the environment, but you're saving money as well. Just as in solid waste, where there's a hierarchy of reduce, reuse, recycle, there's a hierarchy in energy savings as well. Conservation measures are those kind of simple, no-cost, low-cost things you can do you're on your own, turning lights off when you leave the room, lowering the temperature of your thermostat, those kinds of things. Those really should be the first things you do. Next is efficiency, buying more efficient appliances, buying energy efficient light bulbs, those kinds of things. Getting the same output for less energy because it's being used more efficiently. And then after you've done those things, look towards replacing the amount of energy that you still do need to use with renewable energy. Renewables are more costly, so you want to try to first lower the amount of energy that you're using and then look towards renewables. In terms of conservation measures, one of the easiest things to do is turn your thermostat down. For every 5 degrees you lower your thermostat for 8 hours a day, you'll save about 5% on your heating bill throughout the year. So you can just play with those numbers however you want, but let's say you turned it down 5 degrees for 24 hours, you'd save about 16% off your heating bill. Now, what a programmable thermostat does is it allows you to set those temperature setbacks to whatever temperature you want at whatever time you want, and then bring it back up to temperature whatever time you want. So it would allow you to, for example, set it way back 15 or 20 degrees, which might seem kind of chilly to you when you got home up in the morning or home at night. But instead, you just program the thermostat so it comes up, an hour before you get home, so that you feel comfortable in setting it way down and yet and saving all that energy, and yet it's still comfortable when you get home. And also, you don't have to think about turning it down every day. It does it automatically. So that's kind of the advantage of a programmable thermostat. Tuning up your furnaces, boilers, your heating systems. You want to make sure that they're running efficiently. This is a furnace, an old furnace with lots of runs. You can see they've got duct tape on here, and you can see that it's coming off in places. Duct tape, despite its name, shouldn't be used on ducts. Who knows why? I guess they wanted to sell the product. But what happens is, as duct tape gets warm, the adhesive on the back melts and it just falls off. But there are a couple of products that you can use to seal your air ducts. It's quite easy with this product. It's a foil tape, and you just peel it off. It conforms to shapes, and you just tape all the seams in the duct system. There are high temperature and low temperature tapes, so get the high temperature tape. There's also a product called Mastic that comes in a tub, and you apply it with a putty knife, and you just caulk it right on there, basically. You should every year about every year, if you have an oil system, you want to have it tuned up, because oil burns relatively dirty and you can gunk up the burning mechanism. So have a heating contractor come out and clean out and tune your oil burning heaters every year. Gas, propane, you could probably do about every other year. Make sure you clean out your air filters, because again, if those are all clogged, the motors are having to work harder to pull the air through it, and there's more strain, more electrical use. And then again, after you have at some point you can look at changing your heating system. Unless your heating system has died or really, really bad, it's better to first do the efficiency measures on your home and then to look at changing your heating system. And there's a couple of reasons for that. First of all, if you do your efficiency measures on your home, you're going to lower the heat load, how much heat you need to put into the house to keep it warm. And by doing that, you can therefore buy a smaller heating system. When you go to buy a heating system, work with a heating contractor who actually measures the heat load of your house and sizes your heating system to what your actual needs are. Don't do it the way they used to do it, of just square footage of space, because that won't tell you what your real needs are. So you can buy a smaller heating system. It'll be cheaper. You can put that money into doing the efficiency work. The other thing is, if you first do the efficiency work, then if you first buy the heating system, then do the efficiency work, you're going to have a heating system that was sized to your previous needs. It's going to be oversized for what your current needs are, and it's going to cycle on and off and on and off, and it won't burn as efficiently as a properly sized system. You can lower your hot water temperature to 120 degrees, and that should be 120 degrees at the tap, not at the tank. But if you turn your hot water on now and just let it run and put your hand under it, and you can't hold your hand under there, your temperature is too hot. You want to lower that temperature to a point at which it's quite warm in your hand, but not too hot to hold your hand under there. And if you have a thermostat, 120 degrees is what ideally you're looking for. The issue here, and it's the same thing with turning the temperature down on your thermostat, heat loss from the house or from the hot water tank is a function of the difference of temperature from inside to out, or from the hot water tank to the temperature of your room. The greater the difference in temperature, the faster you're going to be losing heat. So if you lower that temperature of your hot water to 120 degrees, you'll slow down the heat loss. Obviously, wrapping your pipes with this foam insulation wrap is a good idea. Putting a hot water tank. If you can feel on your hot water tank and you can feel heat coming out, that's an indication that you're probably either due for a new hot water heater, or you should wrap it with an insulation blanket to try to keep that heat from losing out the tank. Low flow shower heads and faucet aerators also reduce the amount of water use that you have. Washing your clothes in cold water, full loads, air drying outside when possible, and using front-loading Energy Star rated washers will all save energy and water. Phantom loads, or vampire loads. This is Halloween, perfect time for this. These are called either phantom or vampire loads. Are When you have, there are a lot of electrical appliances and devices that you have in your house. Anything with a little LED light that tells you what time it is, or a little red light that you see anytime. TVs, stereos, computers, all the equipment that goes with those, microwaves, all of those things, you have, when you turn them off, they're not off. They're still drawing small amounts of electricity, and it can amount 5 to 8% of the electricity in your home. So you should put all those things on power strips and turn the power strip off when you're done using them. They do have a pretty cool thing called smart strips now, which you can plug your computer into one of the outlets on the smart strip, and if you go away for half an hour and your computer powers down, it will also power down all of the other electrical devices that are plugged into the other portals on that strip. There was one other thing I was thinking about. Oh, I know. This. Other things that will be drawing power when they're plugged in are any chargers, like charging a phone or any kind of a battery charger, even if the thing is fully charged or it's not in there at all, as long as it's the charger is plugged into the wall, it's going to be using power. Compact fluorescent light bulbs. They use about a quarter of the electricity as regular incandescent light bulbs. So these are a no-brainer. Everybody should have them. They do have small amounts of mercury in them, so make sure that when they burn out or if they break, you save them and take them either to your household hazardous waste collection, or a lot of places now, hardware stores, I think the Ace and True Value hardware stores, I think Home Depot, I know the Hanover and Lebanon food co-ops will take compact bulbs back for free to recycle, even if you haven't bought the bulbs there. Energy Star appliances use 10 to 50% less energy than new appliances. So when you go out to buy a new appliance, definitely look for the Energy Star label. You can also go online to EnergyStar.gov, and you can look on there. There's a place where it rates all of the new appliances out in terms of how much energy they use, so you can compare one to another. In Vermont, Efficiency Vermont, and here's the contact information, often offers rebates, discounts on Energy Star rated efficient appliances. So if you're going to buy a new one and you live in Vermont, check Efficiency Vermont out. In New Hampshire, all of the electrical utilities have a program under what's called New Hampshire Saves, and I think it's nhsaves.com on the internet. I meant to do this at the beginning. I just want to get a sense here. How many folks are homeowners? Because I know there's probably a lot of students here too, okay? So about half. How many are Vermonters? Vermont homeowners, okay? And how many are New Hampshire homeowners? All right, so got it. That just gives me a sense of who I'm talking with here. I really should have my email turned off. Apologies for that. All right, we can go on. So this is just a summary. Turn it off, turn it down, tune it up, buy smart. Okay, now we're going to talk about heat loss and how do you go about addressing those issues. And can I get an idea on what time? We have till 4:30, but it'd be good to leave some time for Q&A. Just want to make sure, okay? Okay, so there are three pathways through which buildings lose heat. We're going to really focus primarily on this one, but a little bit on conduction, not much on radiation. Radiation is if you were standing outside on a cold day but the sun is shining and you feel the sun hitting you, that's radiant heat waves hitting you and you feel warm. If you have a wood stove and you feel the heat hitting you off the wood stove, that's radiant heat hitting you. Conversely, if you're standing next to a cold window, I mean, it could be drafts coming in, but it also could be your body radiating warmth from your body to the window and you feel cold. But that's about as much as we're going to talk about radiant heat loss today. The biggest source of heat loss in most buildings is through convection. Conduction is heat moving through the wall, and that's a matter of how well insulated the wall is and the building materials and things like that. And we'll talk a little bit about that later, but we're going to talk mostly about convection, and that's heat moving like a liquid through the air, being pulled out of the house through leaks in mostly the attic or the upper part of the house, and then pulling cold air in the bottom. And we'll talk about that now. What happens is warm air is lighter than cooler air. So the air in your home, when you warm it up, tries to lift and push up and out of the house because it's got less pressure, or it's lighter, and it's pushing up and trying to push out openings high in the house. And what that does then is create a lower pressure in the bottom part of the house where it tries to pull cold air into the house. And you can see that this is kind of a gross example of that happening here. This is where the second floor ceiling is, and there's all this leakage of heat up into the attic space where it then melts the snow off. The melted snow, ice, water comes down, and when it gets to the place where there's outside what's called the thermal boundary, where there's no heat any longer, it freezes and you get these huge ice dams. So if your house has anything like this, melting of snow off the roof and big icicles, it's one indication that you might have a problem. Or, as we like to say, an opportunity. So what you're looking for is a thermal envelope, a thermal envelope and an air barrier that are contiguous, that go all the way around the house, unbroken. And you want the air barrier on the inside, right under the thermal barrier, and right next to it. And you can think of the air barrier kind of like a shell or a windbreaker, and the thermal barrier like the sweater. You can have a lot of insulation, or you can have your nice warm sweater on in the winter, but if you go out and it's a cold, windy day, that's going to cut through the sweater and you're going to be cool. You need something to break that airflow. It's the same thing in your house. You need that shell on the inside to keep the warm air from pushing up and out of the house and pulling the cold air in. So here are a bunch of typical air leak places throughout the house, and we'll kind of zoom in on these and talk briefly about them now, and then we'll go over them in more detail later on. Around vents, bathroom fans, along the edges, if they haven't been caulked, or if there's not some kind of a foam weather stripping around there. Recessed lights are really bad. There's actually holes in the cans unless they're an air-sealed can, and it can go right out through the can or again around the edges. Interior partition walls can act like a channel, and it can pull air into the wall, like through a socket down here, and go right out through the attic. This is a plumbing fixtures, plumbing stack. Around those, around the attic hatch. Those are all areas where warm air typically goes up and out of the house. Here are some areas where they come in, an electrical outlet around doors and around windows. Here are some more. Chimneys are a huge one. You know, in most houses they have, well, in all houses you're supposed to leave a couple of inches of fire break between the chimney and any combustible material. Now, if the builder has built it right, they've also put, even though they have to leave that break of chimney to combustible material, they should have gapped that, filled that gap with a metal flashing. But if they haven't, then, or some other non-combustible material, but if they haven't, it's a huge heat loss place right there. More recessed lights. Here's the cold air coming in through the windows again and through the kitchen vent. And here's cold air coming in. This is a big one around the rim joist. Right where the wood sits on the foundation is a big one. Any plumbing or electrical penetrations that go through the foundation, these are all cold air places that they come in. Windows low in the basement. Okay, so now we're going to talk about, those are some ideas of places where they typically do come in and out. The hot air goes out and the cold air comes in. These now are some ways that you can go about trying to identify and find some of these areas. And it works best on a cold, windy night just because that's when you're going to have the greatest amount of air leakage out of the house, and it'll be easier to feel it and find it. So the easiest place is, the place is low in the building because it's going to be sucking cold air in, and you can feel it. It's basically, you just go around and feel for that cold breeze coming in. It's harder to do that upstairs because it's warm air going out, and it's not like the breeze is going so fast that you're going to feel a huge breeze going past your hand when it's warm. But what you can do is take something that smokes, like incense, and hold it around these areas, and you can see the smoke being pulled up and out these open areas. Another thing is to look for fluttering cobwebs. Spiders are our friends. They build cobwebs in places where air moves often, and if you can see the cobweb flutter, it's because air's blowing past there. And it says dirty cobwebs or dirty fiberglass, and the reason for that is, and I'll probably harp on this more, but fiberglass is a really bad insulator, but it's a very good air filter. An insulation material, in order for it to work, needs to trap air and keep air from moving through it. Fiberglass doesn't do that. Fiberglass lets air move through it very easily. They use it in filters. But they've done a great job about selling the product. So one way to find air leaks up in your attic is to pull back fiberglass, if you have it in your attic, in some of these places that we've talked about, and you can see a dirt streak there. If your house is old enough that it's been going long enough that you've got air going through there and pulling out the dust and dirt from your house, you'll see a dirty streak, and that's an indication that you've had air moving through there for a very long time. Ice dams, frozen pipes. If you have a frozen pipe, it's not usually because your whole basement is below freezing. It's usually because there's an air leak in your basement and it's blowing cold air right on your plumbing in a certain area. So if you've got a frozen pipe, feel around and identify where that air leak is coming in. Okay, so those are some things that an individual can do to identify where heat loss is taking place. Now I'll talk about how the professionals do it. This is a blower door, and that's what's here. Up here they're doing a larger building because they have 2 fans going. They have a bunch of manometers. This is a blower door. You put it in an outside door, close all the windows and doors in the house. This cover comes off, and you can open different openings for the fan depending upon how big and how leaky the house is. And then there are hoses that connect the fan to, this is called a manometer. And what that does is it measures how leaky your house is. It can measure the volume of air flowing through the fan and figure out how leaky is your house. And also, you leave it running and go around and feel where all the air leaks are coming in. Okay, so that's one of the tools that the energy auditor would use. The other tool an auditor would use, and we'll see if we can make this work. We played with this a little bit before, is an infrared camera. And it's going to be hard for you all to see back there because it's a small screen, but you can come up and look later if you want. But basically, this, I'm showing some people out in the audience there now. And those are, yeah, please wave, thank you, that gives you an idea.
You're so hot.
You're so hot, that's right, that's right.
What am I up to?
98.6, I think. So, an infrared camera, and this is kind of a bad shot of one, and the next one's not much better. But an infrared camera measures heat loss, takes a thermal image of heat. And so this is a digital camera, and this is the baseboard, this is an outlet. This is an IR, an infrared picture, and you can see here this dark spot is cold air being pulled in. I'm assuming that they're doing this during a blower door test. Maybe not. You might get that much pulling in and that bleeding of the air going up if it was really cold outside and you had a lot of air being sucked in. And this is air coming in around the outlet. It's also, I mean, this could also be, I mean, when you do a test of a house with a blower door and an infrared camera, we'll usually go around and take a picture of the whole house before we do the blower door test, because an infrared camera can see things that you can't see with your eye. Like there may be a point in your wall where you just have a void in insulation. And that's not going to show up necessarily through the blower door test or visual exams, but the infrared camera will see that. And then we'll turn the blower door on, get the measurements, and then go around and take another picture and see the differences. And I mean, it could be that this is a second floor wall and the air was, before we did this, was being sucked out here and up. But when you turn the blower door on, you're creating the suction and you're sucking the cold air from upstairs down through the wall and out through the baseboard. Okay? Next. There you go. Okay, so those are a couple of things that a home performance contractor would do, a blower door test, a visual inspection of the building. But we also take kind of a holistic, whole house approach to looking at the building. It's a system. Your home, your buildings are systems, and they need to be looked at that way. It's not just looking at the heat in isolation or the efficiency, the energy efficiency in isolation. Because as you start to do things to a home, like tighten it up, you start to affect other things. And things that might not have been a problem before could become a problem. So you have to test for those things before when you come in so you know what kind of baseline you're starting with, and test for them after you've done your air sealing so that you don't get yourself in a dangerous situation. We do combustion efficiency and safety tests. We'll test the efficiency of your combustion appliances. We also do what's called a worst case depressurization test, where we turn all the fans on in your house and then turn your combustion appliance on, and within a minute of the combustion appliance turning on, you shouldn't be able to detect combustion gases being sucked into the house any longer. That can become a problem even more so when you start to tighten up a house. It's easier to backdraft a house. But it does happen even now in some houses that we go in to test. People who have a big range and they have a huge one of these commercial sized range hoods, we've seen houses being backdrafted now and they're not aware of it. So, excuse me.
What do you mean backdrafting?
Backdrafting means sucking the combustion gases back into the house. The fans are strong enough that they're overcoming the natural draft tendency of the warm air trying to push up and out the chimney or the exhaust pipe, the fans are stronger than that pressure of pulling up from the warmth, and they're pulling those combustion gases back into the house.
So that wouldn't apply to a direct vent?
No, direct vent sealed combustion appliances don't have that problem, and that's when we recommend somebody's get a new system, we often recommend getting a sealed combustion unit. Another thing that we test for or look for is moisture. Again, there's a lot of old houses out there that are really leaky and have very damp basements. And there may be some must in the basement, or even not too much because air is moving through there so quickly. But as soon as you start to tighten up the house, that moisture is going to create a problem in the tighter home. You're going to get mold, you're going to get mildew, you could get rot, and you could create an unhealthy situation. So one of the things we do is look for moisture and give suggestions for sealing, or for addressing that moisture and getting it out of the house. The other problem with moisture is if you've got a very leaky basement, and let's say again some of these old homes have dry laid stone foundation, and one of the recommendations for air sealing and insulating those often is spraying 2-part foam on them. But if you haven't first dealt with the water on the outside and you've now sealed them completely, you've created a potential for some real problems. You've got the potential of water pressure backing up enough that you're going to push in on that foundation. You've also now got a pool of water backing up there. You've also created a colder area around the outside of the house because it's no longer getting that warmth from the foundation, and that outside ground that might not have frozen tightly all the time may well now freeze and have a bunch of water there. It's going to expand, and it could create problems inside for the heaving the foundation. So there are just a lot of things that you really need to think about and know about, and that's some of the things that we look at. After we've looked through the house, we develop a priority list, a report with a priority list of recommended improvements. We'll generate an idea of how much energy you could save through the retrofit measures that are recommended. Surge does not do retrofit work. We only do energy audits, and then we give referrals for other contractors who do the audits. But some of the home performance contractors do the work themselves also, and they can give you the costs for renovations. But if if you were doing it from us, you'd basically take our report, go to them, they'd look at it, give you a cost, and then you can kind of get an idea of what's the payback period for doing this kind of work. And then in Vermont, you also have some state financial incentives that may be applicable to you. And if you go through the Home Performance with Energy Star, you have access to those financing options. Again, you can check with Efficiency Vermont, and they can go over all of those. Well, we'll talk about it here in a minute, but there's also a federal 30% tax incentive on the cost of materials through the end of 2010 at this point. And that's on materials only, it's not on the labor. Okay, now we're going to quickly go over how do you do some of these air sealing measures. And we're going to do them in this order because this is kind of the order that's most cost effective usually, because it's easy to access the areas and to address them in the attic and the basement, usually because they're unfinished spaces and you have easy access to them. Also, those are the places where you have the greatest air movement, the warm air pushing up and out and the cold air pulling in. The middle part of the house doesn't have that huge pressure dynamic going on, and also it's a finished space. And so changing windows out, which is unfortunately what I often hear somebody say they've just done, oh, I just changed all my windows. And I say, oh, it's really too bad. I try to be nice about it, but if that money was instead put into doing some of this other air sealing and insulation, you'd save so much more energy at much less cost. And then there are things you can do to retrofit windows, and we'll talk about that again in a minute. Okay, so these are broken down into, what are some basic things you can do, and what are some more advanced, and whether you feel comfortable doing any of them or all of them depends on kind of your knowledge level and your practice level. So I'll kind of leave that up to you. So we're going to go over, except I will give you warnings. There are some things that you really want to be careful about when you do, because again, you can create problems, and we've already talked about a couple of them. We'll talk a minute about some different materials to use. This is a foam gun. You've probably all seen the one-touch, what is the foam? Great Stuff, thank you. The one-can use, basically, of Great Stuff. That works. The problem with it is, once you start using it, you have to use the whole can, because if you stop, then it's gone. It seals up and you can't use it anymore. And you also really don't have a lot of control over how much comes out. These foam guns are great. You do have to make sure you keep them well cleaned when you're done with them. You also have to make sure that when you're done using it, you screw this in all the way to seal it. Otherwise, you're going to leave the end open, and you're going to get this will harden up, and then it won't be any good anymore. And you have to keep a can on it for the same reason, so that it doesn't harden up at this end. But as long as you keep it cleaned out periodically and keep it well sealed, these work for quite a while. You can control how much foam comes out, and they're a really good tool for kind of do-it-yourself home air sealing. And you can come up and look at these things later. It's going to be a little hard for some of you to see them back there, but here's a board with some different insulation and weather sealing products on it. This is the foam from that gun. This is polystyrene insulation board. It's an R5. R numbers are measures of resistance to heat movement. The larger the number, the better the insulation, the better it insulates. So this polystyrene is R5. This is polyisocyanurate, foil-faced foam, and that's an R7. This is a little foam weather stripping. This is the V-shaped weather stripping, which is often used in window applications. This is a product called Q-Lon. It's a little hard to see, but it's kind of a door stop with a vinyl-covered foam weather stripping on it there. Here's some of that foam foil tape. Here's some acrylic latex siliconized caulk, some fire-rated caulk. We'll talk about where that can be used, and then some rope caulk. Here are a couple of other products. This is cellulose insulation. You can come up and look at it. Used in some different applications we'll talk about. This is vermiculite. This is something you don't want to use. This is something you don't want to get into. Actually, you can't use it anymore, but it was used during a period kind of from the, I don't know, maybe mid to late 30s or 40s through the early 60s. And unfortunately, some of it can have some asbestos in it. And so it's nasty stuff. You can come and look at it and just make sure you don't have any of that in your house. If you do, you should get it taken care of. This is a plastic window coating, kind of an interior storm window. It's called Tizol. It's got a 2-track system. There's an outside track that peels off. The bottom track has adhesive on it and sticks on the window trim or casing. You put the film across it, and then you snap the top track in place, and it will seal the window on the inside. You put that on in the winter. When you're done with it, take it off, wrap it up, and you can use it again the next year. This is a tank wrap, one of the few places where they actually do use fiberglass where it's okay. it's better to have a new, more efficient hot water tank with foam on the inside. But if you're going to retrofit, this is one thing you could use fiberglass in. It's got a vinyl outer covering and then some fiberglass on the inside. This is a foam gasket that can go around your outlets, and then a little plug that goes, it's a child safety plug, but it also helps keep the air from going through the outlet. There's some other things up here, a programmable thermostat low flow shower head. Okay, now some of the different things you could do on your own include, and I'll tell you now, I'm wondering if I can leave it with the Thayer. I have a half-hour DVD, and actually you can also contact me directly if you'd like to borrow one. I'm not sure I might have one with me here, but we have a half-hour DVD that Serge helped produce, which kind of leads you through step by step doing a bunch of these do-it-yourself air sealing measures. I'll leave one with Thayer if anybody wants to borrow one. But I have some that you can get through me too. Okay, so this is an attic hatch. Yeah, shooting myself. This is an attic hatch, and what we've done is put that foam weather stripping all the way around the ledge that the hatch sits down on, so that it air seals right there. And then we've put 6 inches of foam board and taped the edges with that foil tape, so you don't have air moving through the different layers of foam insulation. This is sealing wiring penetrations that are coming up through the attic. This is actually an electrical box for a light, a ceiling light fixture that's down below. And you can see there's gaps all around it and through the box itself. There's a couple of ways you can do. You can take that foam gun and spray all around it with foam. Or this is that product I was talking about called Mastic. And you can just slather that around all the openings as well to seal it. This is a plumbing penetration. This is very typical. A vent pipe coming through, and this is an interior wall. So this is a plumbing stack coming out, and you have a huge area there for air from down in that wall to come up and into the attic. And you just take the foam gun and spray foam around there. Same thing, this looks like a telephone wire that's coming up through there, and you can do that, spray that with foam. This is another area. This is okay, so this is the top plate of the interior wall. Here's the ceiling sheetrock, and then there's a piece of wall sheetrock right there. The gap, there's a gap right between the top plate and the wall insulation that air from inside that vertical interior wall can come up and out that gap right there. So you can either caulk that or spray some foam along it. Okay, this is the one, and note that it says advanced. I'll kind of tell you briefly how you do it, but a lot of folks might not want to do this because it needs to be done right and you don't want to mess it up. This is a chimney right here. And again, around the chimney is this 2-inch fire break. And what they've done here is they have taken a piece of metal flashing and bent, it's long enough that you can bend one leg to go from the chimney over to the framing, and the other leg you bend it and it goes up along the chimney. This one that comes over here, you'll put regular caulk on this framing, take the metal flashing and caulk it to that, and caulk it and nail or screw it down into this framing going along here. Over here, you want to use that fire-rated caulk between the flashing and the chimney. You don't want anything that can be flammable next to the chimney. And then at the corners, where the flashing coming on this side is going to overlap, you're going to cut it and let it lay down flat over itself. You're going to use fire-rated caulk to seal those gaps at the four corners where it laps over itself. This is a up in the attic looking at a knee wall kind of, and they have used foam board in the slopes and then sprayed foam along the bottom. Yeah, I don't like this picture. It kind of doesn't tell. It's kind of hard to explain what all is going on there. But basically that's just showing a detail, one thing you can do, way to seal that up in the attic. Okay, we're going down to the basement now. This is a bulkhead door, and again it can be a very leaky spot for cold air to come down into the house. You'd seal this just like you would any of the doors in the house. You'd use this Q-Lon weather stripping all the way around the door. Basically you shut the door till it latches, go from the outside, cut the 3 pieces of Q-Lon to shape, put caulk around the back side of them so that when you put it in place, air doesn't leak through the back of it. You push it against the door, but you only push it about halfway as far as this will compress. If you push it really hard and then nail it into place and then open the door and try to close the door, you won't be able to close the door because it's too much pressure. So push it about halfway, put the nail about halfway in, let it stick out. Open the door, make sure you can close the door, and then you can set the nails home. This is the rim joist. Again, it's where the plate, the bottom piece of wood, meets the foundation. And that's a very leaky area right there. And so what they've done is put a piece of foam board in here, undercut it, spray foam around the edges, and then spray foam around this gap and all the way around the bottom plate. And I'm not going to get into it now because we really don't have time, but you can insulate the basement wall, but it's one of those things that if you don't know how to do it, don't do it, because you can get yourself into trouble again about creating a freezing space and moist air getting back there and creating problems. Fireplaces are big heat losses. Even when you're using them, you may feel warm right in front of it because of radiant heat coming out to you, but they suck so much air into the house to burn the fire, and then so much of that heat goes out the chimney that they're a net heat loss when they're working, and then they're bad when they're not working, because often either there's no damper or the damper doesn't seal well. There are ways you can seal those, putting an inflatable pillow in there, or if you don't use it, put a piece of foam and caulk it around in there. Windows, I'm going to skip right through these because we're about out of time. Windows, there are a lot of things you can do in terms of weather stripping and putting storms on, caulking, that'll make them much more efficient, and they're really pretty expensive to replace and not usually a cost-effective opportunity. Conduction, we talked about, is heat loss going through. The higher the R value, the better the insulation. This is a contractor blowing cellulose into an attic. You can do this on your own. You can rent a blower, have somebody downstairs outside filling the hopper with cellulose, and somebody upstairs blowing it in. It's kind of a nasty job. You get a lot of dust. Make sure you wear at least a very good respirator or dust mask, if not a respirator. This is a contractor dense packing a wall with cellulose. You can put loose-filled cellulose in an attic after you've dealt with the air movement, but you want to dense pack walls. Dense packing is blowing the cellulose in up to a certain amount of pressure for a couple of reasons. One, it will keep that cellulose from settling. When they used to do walls with cellulose, you'd go in a few years later and you'd find a gap at the top of the wall where there's no insulation because that cellulose had settled. When you install it in a dense packed fashion, it won't settle, and it also won't let air move through it as easily as loose filled. It's another example of a house that's gone through this process. Cost that much, they save that much per year, that much fuel, and it's about that payback. Again, health and safety issues. When you start tightening up the house, you really need to be aware of these things. Every house should have a carbon monoxide detector on every floor of the house. You got to test before and after to make sure you're not getting backdrafting into the house. Got to deal with moisture, and radon is another one that got to think about. Volatile organic compounds. If you have paints and all those kinds of things in your basement, it's great if you can find a place to get them out of the house or seal them up so that they're not their fumes or vapors are not coming into the house. One big problem is people having attached garages, especially under-house garages. They store a lot of things in there. They start their cars. It releases a lot of carbon monoxide. Leave your cars running to warm up. And if your house isn't really tight and this garage is on the bottom, you've got this system where warm air is going up, the air in the bottom's being pulled in, you're getting all those fumes being pulled into the house. We talked about asbestos or vermiculite, asbestos on old pipes. They're sometimes used for insulation on old pipes, and lead in paints. Home performance contractors do their jobs on a fee-for-service basis. I strongly encourage anybody who either qualifies for low-income weatherization or knows somebody who does to let those folks know about this program and apply for it. There's about a 1.5 year waiting list now, but they will come in and do a free blower door test and free retrofit measures for anybody who income qualifies, and the income levels have risen because more money is becoming available. So if you think you might qualify, check for that. These are the different agencies that run those programs in Vermont. There are agencies that run it in New Hampshire. In either state, you can dial 211 and ask for information about the low-income weatherization program.
Out of curiosity, do you have an idea what the federal level is?
Oh, the income levels? I do, and I think it's coming up here in just a second, but at least for Vermont. Okay, so energy audits cost $300 to $1,000, and we've kind of gone over what they deal with. This is the Efficiency Vermont contact information. Look it up on the internet. 30% financial tax credits. We talked about some of this other stuff. Oh my goodness, I removed that slide. I'm really sorry. There was a slide in here that had, and I don't know why I took it out. It had income levels for how many people in the home. Call up 211, get the weatherization, and call them up and ask them. Sorry. If I can find, I may have it up here and you can check with me afterwards. So this is just kind of a summary of a bunch of things we've talked about. And thank you.
We have time for just a couple of questions.
Yes.
If you have a two-story house with fan lights on the inside that you can't get to from above, and also if you can't get to it from above?
Yeah, you can replace recessed lights with, they do have leak-free or lights in recessed lights that you can buy, replacement canisters, and you can do that. You can try to do some retrofitting and try to pull the can out, and with that foil tape, tape the parts where there's air leakage going out, and then caulk the edges when you put it back in. But you want to look on the inside of the can and see if it says IC rated, which means insulation contact rated. If it isn't that and you do those things, it's going to overheat. Okay?
Does it make any sense to seal gaps between floors? So from the basement to the first floor, from the first floor to the second?
You don't really need to do that. What can be a problem, you can do a blower door test and see air being pulled out of, let's say, a first floor light fixture, but where that's being pulled from is it's going out the joist bays to the rim joist. So you do want to seal, you may have to seal all the way around the rim joist between floors, but you don't really have to seal between floors.
The basement door or the door to the second floor?
The basement, you might seal the basement door just because that's quite a bit cooler. I don't know, you're not going to have a lot of air movement that direction because it's warmer up and cooler down. Yeah?
Can you explain why fireplaces build a net heat? Can you hear me?
I'm sorry, I missed it.
Sure. Can you explain why fireplaces have a net heat loss if your house is so warm? If you shut a fire and your house gets up to 80 degrees, how is there still a net heat loss?
Well, you're only going to be warm and get the house warmer right in the immediate area where the fireplace is. But fireplaces take so much air to burn because it's a free burn, and they're putting all that, they expel a lot of air and a lot of heat up and out the chimney, much more so than a contained heating system. And so what happens is, because of all that cold air that they're pulling in from the outside around the house to feed that fire, even though you're feeling warmer right here, the overall heat temperature of the house in general is being lowered.
Okay, I think in the interest of time we should have other people ask their questions privately. Let's thank our speaker again.